Okay, so this is the last section of Unit 6, and we are going to be talking about polygons in the coordinate plane, which means we're going to be using our formulas that we've used before, like slope, midpoint, and distance formula. Okay, but before we get to that, let's classify these quadrilaterals based on their definitions. So we really want to focus on what makes the shape what it is, the definition, not necessarily the properties, but the actual definition. Okay, so we'll do the first one together, and then I'm going to let you guys finish it. But what is A? Bless you. It's a rhombus. It's a rhombus. If you said parallelogram, you're right, it is a parallelogram. But this says, you know, it actually should say, what is the most specific name for this quadrilateral? Based on the markings, what makes this a rhombus? Yeah, so it's a quadrilateral with all 4 congruent sides. And that's what makes a rhombus a rhombus. Okay, so I'd like you to try to classify B through F and give a little reason based on the definitions we've learned. Okay, so this one should be kite. And it's a quadrilateral with 2 pairs, good, consecutive sides, congruent. Okay, so that's just a reminder of what those definitions are and what makes the shape what it is. That's going to be important as we think about these things on the coordinate plane and figuring out what kind of a shape we're given. Here they tell us that they're giving us kites. And they want us to find the area of each kite. It's drawn on the coordinate plane. So in certain cases, A and B, we can just count out what the diagonal length is. When you count out the diagonal length, plug it into the formula, you get your area. So try A and B. So when we count the boxes, we get 5 this way and 6 this way. That's our D1 and our D2. Plug it into the formula, we get 15 square units. Okay, so try B. When you're counting the diagonals, you can just count the boxes 1, 2, or you can, you know, look at the numbers that they have on the axes. For this longer diagonal, here's your, I should do that in a different color. Okay, so here's the y-axis, right? So this diagonal goes all the way up to the 6 on the positive side of the y-axis, and it goes back to the 2 before the y-axis, right? So there's 6 on this side, 2 on that side. That makes one of the diagonals 8. What's the other diagonal? 2. So this one should be 1/2 times 2 times 8 is just 8. 8 square units. All right, let's look at this last one. I need the length of this diagonal and the length of this diagonal. Can we count those out? No. Can't count them. How do we find the distance from one point to another point on the coordinate plane? The distance formula. So we need the distance formula in order to get the area of this kite. So the first thing we should do is really establish what our ordered pairs are. What's the ordered pair for Q?
We got a 2 and
2, 2. Good. And R is?
R, we got a solid 4, 1.
4, 1. Good. And S is?
S, I'd say 5, -1.
Good. And T is?
He's like a 1, -2.
Excellent. Okay, so if we want to get the length of this diagonal from Q to S, we need to find the length of QS. And that's going to give us D1. Okay, so the formula for that is actually on the next page. But we'll remember it's x2 minus x1 squared plus y2 minus y1 squared. So we're going to subtract the x's, and we're using Q and S. So this one and this one. Subtract the x's, it's going to be 2 minus 5. And subtract the y's, we're going to do 2 minus a -1, which is +1. 2 minus 5 is -3 squared, plus 2 plus 1 is 3 squared. We get the square root of 9 plus 9, or square root of 18. How can we simplify that radical? What is a perfect square that goes into 18? 9. Good. So root 9 times root 2 is 3 root 2. So that's the length of QS. Let's do the length of the other diagonal, which is what?
T to R.
TR. So again, we're going to subtract the x's, 4 minus 1 squared, plus 1 minus a -2 squared. 4 minus 1 is 3. 1 plus 2 is 3. Again, we have the square root of 18, which is 3 root 2. I'm not sure if you still have some room on your page, but now we need to find area. 1/2 d1 times d2. Well, this happens to be 3 root 2 and 3 root 2. We're both diagonals. So we've got 1/2. What's 3 root 2 times 3 root 2? We're going to do 3 times 3. Careful. 3 times 3 is 9. And what's root 4?
2.
Right? You got root 2 times root 2 is just 2. Remember, you don't really have to think of it as root 4. Just remember, something, square root of something times the square root of that same thing is that number without the radical. So root 2 times root 2 is just 2. So you got 1/2 of 9 times 2 is just 9. 9 square units. Okay, so we are going to be using these formulas again in the coordinate plane. There they all are written out for you. Distance formula, midpoint formula, slope formula. So what we want to remember is what these things actually do for us. What do they help us find? And since we're talking about the properties and the definitions of quadrilaterals, what we're going to do is be classifying quadrilaterals that we put in the coordinate plane as, you know, a rhombus or a rectangle or a square or whatever it is based on its property, its definition. So what we have to do is figure out what's true using these formulas. So things like, you know, opposite sides are congruent. Well, to figure out if two things are congruent, which formula would we use? If two side lengths are congruent, what formula would we use?
Distance.
These are just some connections to kind of make when you're thinking about these formulas. The distance is literally the distance from one point to another point. Well, if you connect that, distance is the same thing as saying the length of something, right? From one point to another point, it's the length. If you're talking about a polygon, the distance from one point vertex to another vertex, you're going to get the length of a side. If you go from one vertex to like the opposite vertex, it could be the length of a diagonal, right? But you're talking about the length of a segment when you're talking about the distance formula, okay? What about this next tip here is just remember that the midpoint is the average of the x's and the average of the y's. It's a halfway point of where the x's coordinates are and the halfway point of where the y coordinates are. So that formula, although it may look a bit, funky and complicated, you're just adding the x coordinates together divided by 2, adding the y coordinates together divided by 2 because it's the average of each. All right, the last three things here are all about slope. Slopes that are equal indicate lines that are parallel, right? So if two lines or two segments have the same slope, that means they're parallel to each other. If two lines or segments have opposite reciprocal slopes, opposite reciprocals, that makes them perpendicular. So for example, if one slope is -2, then the perpendicular slope would be what? Opposite reciprocal. Opposite means you change the sign. So would this perpendicular one be positive or negative? Positive. And then the reciprocal of 2 would be what? 1/2. Right? Opposite reciprocal is changing the sign. One's positive, one's negative, and then flip it upside down. Okay, but what does that mean? When we're talking about the definitions of these quadrilaterals, I don't see anywhere where we said the word perpendicular. But what did we say that relates to perpendicular? Right angles. Perpendicular lines are two lines that come together at right angles, right? We got that here, we got that here. So perpendicular means that there are right angles in the shape, in the figure. So if two sides are perpendicular to each other, that's an indication that maybe it's a rectangle or a square because there's right angles. Okay, so for each of these, decide whether you would use the distance formula, the midpoint formula, or the slope formula. If you want to know whether diagonals bisect each other, if we want to know that they cut each other in half, well, if two diagonals cut each other in half, what can you say their intersection point is? The midpoint. So here we would use the midpoint formula. If you want to know whether opposite sides are parallel, well, which of these formulas helps you figure out if things are parallel? Slope. Okay, you guys try the next 4. Okay, so if you want to know whether sides of a polygon are congruent, congruent means they have the same length, which formula would we use? Distance. Okay, let's talk about midpoint formula for a second. Midpoint formula is when you have two endpoints given to you, and you're just trying to find where the point is that's in the middle. So how would we, that wouldn't help us get whether the sides are congruent. How would that help getting us the sides are congruent? It's not going to help. right? So that's distance. Distance, we would have to find the length of the side, the length of the other side, and if the lengths are the same, then you know they're congruent. All right, angles in a polygon are right angles. Is this distance, midpoint, or slope? Why slope? Yeah, because up here we said slopes give us either perpendicular or parallel lines. And right angles are formed with perpendicular lines. So if it says, are there right angles, you're going to use the slope formula to see if they're opposite reciprocals. Okay, diagonals are congruent. Distance, good. Diagonals are perpendicular. Slope. Okay, so anything that says parallel or perpendicular is going to be slope. Anything that says congruent is going to be distance. And then midpoint would be like a bisect each other. Okay, so this is a typical type of question that you're going to have. They give you 4 vertices of a quadrilateral on a coordinate plane. And they want you to prove what type of quadrilateral it is. All right? So let's graph this first. Quadrilateral M, N, P, Q, where we have M is 0, 1. Sorry, 0, 1 is here. That's M. N is negative 1, 4. Negative 1, 4, that's here. P is 2, 5. Over 2, up 5, that's P. And Q is 3, 2. Over 3, up 2. So what shape would you guess that this is? What would be the most specific name for what you would guess this is? If we guess that this might be a square, maybe it's a rhombus, we're not exactly sure because we can't tell just by looking at it, but we think that maybe it's one of those. What we want to do is use our formulas to show or prove or confirm what we think that it is. Okay, so if we do think that it's a rhombus, we would have to show that all the sides are the same length, right? If we think that it is a square, we would have to show that all the angles are right angles. Okay, so what 2 formulas is that? If we're trying to show that the sides are the same length, what formula is that? Distance. And if we're trying to show that the angles are right angles, what formula is that? Slopes. So I'm going to suggest here that we start with the slopes. Slopes are pretty easy to find, and it gives you lots of information right away. If you have all the slopes, you can tell right away if the opposite sides are parallel, if you have 1 pair of opposite sides parallel or 2 pairs of opposite sides parallel, and you can tell if you have any right angles. So just by finding slopes, you get a lot of immediate information. So let's do the slope of, and I'm going to do the 2 sides that I think have the same slopes. So let's start with MN. And what do you think has the same slope as MN? QP. Right? We're thinking that these 2 sides, you know, if it's a square or a rhombus or just a parallelogram, they have to have the same slope. So let's find the slope of MN. Now remember, slope formula is y2 minus y1 over x2 minus x1. So we're going to do subtract the y's of m and n. So 1 minus 4 over 0 minus a negative 1. And what's 1 minus 4? Negative 3. And 0 minus a negative is plus. So that's 1. So our slope is negative 3. All right, let's do QP. QP, we're using these two coordinates over here. We're going to subtract the y's. 5 minus 2 on the top over 2 minus 3 on the bottom. What's 5 minus 2? And 2 minus 3 is, so our slope is negative 3. So did we just confirm that these are parallel? Yeah, same slope, so parallel. Now we're going to do the same thing with the other two sides. The slope of NP and MQ. Slope of NP, again, subtract the y's. 4 minus 5 over negative 1 minus 2. And we get negative 1 over negative 3, which is positive 1/3. And MQ, actually you find MQ. Okay, so the slope of MQ, we're using M and Q. Subtract the y's. 1 minus 2 over, subtract the x's. 0 minus 3. And we get negative 1 over negative 3 again, which is positive 1/3. So did we just prove that these are parallel? Okay. What about, are there any right angles? Because slope is supposed to help us find if there's any right angles. Are there any right angles? Well, which formula do we use to figure out if there's right angles? If we look at the slopes, what would indicate that they were perpendicular? What kind of slopes? Same slopes? No. Same slopes would be parallel, and we already determined that. What are we looking for right angles? Opposite reciprocals. Is negative 3 and positive 1/3 opposite reciprocals? Yeah. So these are perpendicular. These are perpendicular. All of them, all of the consecutive sides are perpendicular. So how many right angles do we have? So there's 4 right angles. So far, we know that we have a parallelogram with 4 right angles. Which means this could be either what or what? Rectangle or square. What's the difference between a rectangle and a square? Yes, good. A square has all the sides congruent. So what formula could we use to figure out if the sides are the same length? Distance formula. That's what we need to do now. Let me ask you this. Do we have to do distance formula 4 times to figure out all the sides? How many times can we do it? Twice. Which 2 sides should we choose? Should I choose like a top and a bottom, or a left and a right? Or should I choose 2 sides that are next to each other? Next to each other. Because we've already concluded that this is a parallelogram with right angles. That means whether it's a rectangle or a square, opposite sides will be congruent. So we don't, once we find one side, we don't need to find the side opposite from it, because it's going to be the same. What we need are 2 sides next to each other. So we're going to do the distance formula on two consecutive sides. Yep, two sides next to each other. So we highlighted these already. Let's do N, M, and MQ. We need the distance formula of these two things. All right, well, distance is, we're going to use M and N. Difference in the x's, so 1 minus 4 squared plus 0 minus a negative 1 squared. 1 minus 4 is negative 3 squared plus 1 squared. That's going to be 9 plus 1 is the square root of 10. MQ, now we're using these two. Again, subtract the x's, 0 minus 3 squared plus 1 minus 2 squared. And you get negative 3 squared plus negative 1 squared. Again, we get the square root of 10. So it's a square. It's a square because all sides are congruent. And there's 4 right angles. And we proved that with our formulas. It is cool. It's mathematically basically proving that a figure is what it is. Okay, so this is a little bit of like practice on testing whether you get this now, right? Whether you understand, if you have, let's look at number 8, if you find that you have a quadrilateral with 2 pairs of opposite sides parallel, what would be the name of that quadrilateral? 2 pairs of opposite sides parallel. That's all you know, is that they're parallel. What would you call that shape? A parallelogram. We don't know anything about the lengths of the sides or anything else. All we know is that opposite sides are parallel. So that's a parallelogram. To determine if the sides are parallel, use the what formula? Slope formula. All right, you guys try 9 and 10. Okay, so there's the answers there. For number 11, this is similar to the one we just did. It's already drawn for us. What would you guess that this might be? Could be a rhombus. We can't tell for sure, but we think that maybe it's a rhombus. What are we going to have to show to prove that it's a rhombus? Okay, so parallel sides and congruent sides, 4 congruent sides. Okay. If we're trying to figure out parallel sides, what formula are we going to use? Slope. And congruent sides, we're going to use distance. So this is really just like that last one that we did. I really do recommend always starting with finding all 4 slopes. You should have come out with either 1/3 or 3 for the slopes. These two are parallel. These two are parallel. Are they perpendicular to each other? 1/3 and 3. Are they opposite reciprocals?
Yes. No.
They're reciprocals, but they're not opposite. So that means that they're not perpendicular. Okay, your homework is to do the back of that packet. There's just 1 page on the back. Okay? Okay, so we've proven that the sides are parallel. We have to see if they are the same length. So again, we're going to do distance formula to figure out if 2 sides next to each other are the same length. So we can do maybe AB and BC. So, you should try to do this yourself. Pause the video and do it yourself. Practice, and then come back and check your answer. Alright, so it turns out that the consecutive sides are the same length, which means all four sides are congruent. So this is in fact a rhombus, because all sides are congruent. And opposite sides are parallel. But opposite sides, but consecutive sides are not perpendicular, so there are no right angles. Okay.